WV2M here. I'd like to share with you a little circuit I put together that adds the capability to the LP-500 digital station monitor of displaying received audio. This is a wonderful monitor. I've enjoyed it very much since I received it a few months back. It displays waveforms from your transmitter, SWR, power output, and also has a spectrum display as well. One of the things that I had in my old station monitor, which was a Yaesu YO100, which is about 50 years old or so, an analog station monitor, was the ability to display received audio. There was an RCA jack input on the back of that unit, and you could display received audio. This unit doesn't have that capability, but you can easily add it by inputting the audio wave form into one of the RJ45 jacks that are available. There are 4 of them available on this unit. Larry, N8LP, who's the designer of this monitor, suggested that it should be as simple as using a voltage divider network of 2 resistors, adding a little bit of bias that is available on the RJ45 jack, and just inputting the waveform directly. What I found helpful was to actually, in addition to the resistor divider network, was actually incorporate a transistor amplifier to this and a buffering circuit as well. And I'd like to show that to you right here. And the way I've designed this is there are 2 pots. The pot on the left actually controls the amplification of the audio input, and the pot on the right actually controls the amount of bias. And I can demonstrate that here as we're looking at the waveform. I'll give you some audio here. So I'm going to now adjust the amplitude, turning it down, turning it up. As you can see, the waveform is getting larger in amplitude, and then I can reduce it by turning it down. And then I can adjust the DC bias by turning the right pot, adding more bias to lift the waveform up, or reducing the bias and dropping the waveform. Of course, when you drop it too low, you'll actually see, nothing will display, or you'll be clipping the negative portion of the waveform. So you increase the bias to the point where the waveform is not being clipped. So that's a good point. So this is a nice capability. I'll switch the display mode. So here I'm displaying the waveform itself. I'll reduce the amplitude a little bit. So in the second part of this video, I'll share the circuit with you and look for any suggestions to help optimize it. Thank you for watching. Bye-bye.